All right, here we go. So we are going to do not these two, because those two are actually pretty easy. They're pretty easy, and pretty much one of those two is kind of like one of these combo threers, right? So we're going to do this one. I will quickly say that impulse and momentum, since they're going to be equal, the momentum is, this says change in momentum, right? So that means initial, and you take away that final, or the final minus initial, excuse me. So if you start off with 4 times 0.1, which is, all right, I'll quickly go through this because I don't want people to get confused. So 4 times 0.1, 4 times 0.1 equals 0.4. Our final momentum, 1 times 0.1 equals 0.1. 0.1, there we go. Therefore, our change in momentum equals 0.4 minus 0.1, which equals 0.3. So what does that mean? That means your change in momentum will be 0.3, which means your impulse will be 0.3, right? Okay, I'll let you do the rest. This is just the momentum first, momentum second, blah, blah. Okay, so let's do this one. This is the only one we're going to do on this page. Not that bad. So let's read through it. A car is at rest when it experiences a forward propulsion force to set it in motion. So it's at rest. It receives a forward propulsion, a pushing force, to set it in motion. Then it receives a second propulsion force to speed it up even more. Finally, it brakes to a stop. So it's at rest. It receives a propulsion force. It experiences a second one, and then it stops. So right off the bat, we know what is the momentum when it's at rest. Because momentum equals mass times velocity. If the velocity is 0, momentum should be 0, right? Bam. All right. So then it receives that force, which is, it receives a 4,000 Newton force over 4 seconds, which means its momentum, its change in momentum to from 0 to 4,000, or excuse me, 0 to 16,000 newtons is 16,000. Bam, bam, bam. Which means our impulse is 16,000. All right. So that's what it's sitting at right now. It's sitting at 16,000 kilograms per meter second, right? All right. So then we've got that. Check, check. Now it receives this. It gets a second force. So our second Newton force, it's 6,000 newtons over 3 seconds. So that equals, what is that, 6,000 times 3? That's 18,000, right? So it gets that force. So 18,000, it's already going 16,000, plus 18,000, that's going to be 34,000. So it gets that extra momentum, so it's up at that. So the change in momentum is just going to be 18,000. Starting at this, it gets 18,000. Goes to that. So that's our change of momentum. Not bad. Okay. Now, so we've done that. Check. It brakes to a stop. So right off the bat, what's our final momentum going to be? If it stopped, it's 0, right? So that ain't bad. Which means our impulse is actually going to be negative 34,000, and our momentum will be negative 34,000. So how do we find the time? How do we find the time? Well, we know that our mass, our momentum, we're just saying mass times velocity, which is momentum. Our current momentum is 34,000, right? Equals our force times our time, our change in time. Well, what do we have? Do we have time? No. Do we have force? Yes. So we got 8,000 times time, change in time, is 34,000. So if we do divide 8,000, divide that out, let's do it. Oop, add another 0. Bam. Change in time equals 4.25 seconds. So there you go. 4.25. Easy money. And that's how you do it. Not too bad. You're just kind of taking it step by step. Rewatch it if you need to. Should not be that hard. Alright, good job, guys.